user because of complexity. Okay, nothing else. So because if the user knows all the details of the IO devices, he may confuse himself. Okay? So that OS job is to hide some information related to the IO device, and IO subsystem responsible for. So this subsystem is responsible for memory management of IO, including buffering, caching, spooling. So these are the three jobs, whether it should spool or cache. Okay, so what these are the responsibility of IO subsystem. Caching. What is caching? It is again the storage. Okay, temporary storage where we can keep the frequently accessed information. Okay, and spooling is also loading something into a particular area. That is spooling. The overlapping of output of one job with input of other job. So where the spooling is the area where some process information should be kept. And what is the other task of operating system in IO management? General device driver interface, to provide, even though you are installing the driver. For example, we can take a system, HP system. Okay, HP system has different IO device drivers, right? Compared to other vendors of, they are providing different drivers. Or each and every system has its own different drivers. Okay, even though you are installed the IO device driver from some other system into HP system, it won't support. Okay, so what the operating system should do, it should give the support for the IO device driver and interface when you are interacting with any IO, or otherwise IO is interacting with the operating system only if the operating system allows the device driver interface. Okay, and then drivers for specific hardware devices, and also maintaining the drivers for some specific hardware devices. Job is done by the operating system. Okay, next. Secondary storage management. Okay, we have seen main memory. Okay, and also we want to secondary storage memory, and all the operating system job is to maintain both main memory and also the secondary storage area. Since main memory, what is the need of having secondary storage memory? Since main memory is volatile and too small to accommodate all data and programs permanently, the computer system must provide secondary storage to back up main memory, to support main memory. Since the main memory size is low, the secondary storage wants to support the main memory. Okay, so that we are having some 80 GB, 120 and 500 GB of hard disk. Okay, so where we can store our data very it accommodate all the data. Okay, whereas main memory is not supporting this. Most modern computer systems use this as the principal online storage medium for both programs and data. So common medium is to store as a secondary storage unit is called this disk. The operating system is responsible for the following activities in connection with disk management. So in disk management, again the space management is done by the operating system. Okay, in main memory also allocating, deallocating the space done by the operating system. Here also the secondary storage area allocation, deallocation is done by the operating system. Free space management, storage allocation, disk scheduling. Okay, as I said, there is a mechanism should be followed for scheduling the disk. Okay, so scheduling the disk space. Okay, how the process making use of disk efficiently for efficient utilization purpose, we need to have the disk scheduling algorithm. Okay, so if you can take an example of this room. Okay, so it is a storage. It is a storage area. Okay, how efficiently I am arranging the chairs here. Okay, here and occupying the space in this room is efficient one. Okay, for that I should follow some mechanism. Okay, so this is what happening in this scheduling. So the job of OS here is to schedule and allocation and also free space management. How efficiently it manages the free spaces. Next. Protection protection system. Protection refers to a mechanism for controlling access by program, process or user to both system and user resources. So how the access rights given to the user or to the particular process, okay, to access any system resources. Okay, so access is given by the operating system so that the user or the process can make use of the resources, okay, system resources. The protection mechanism must distinguish between authorized and unauthorized usage. Okay, so any process, if a virus process is there, okay, virus process can make use of whether the operating system allow the virus process to make use of any system resource. If it allows, something will be damaged, right? System resource gets damaged, so it should not allow. For that, we have a set of virus protection mechanisms. Okay, so that it should identify who is the authorized person or not. Okay, and which is the authorized process and which is the unauthorized process for the system usage. Specifies the control to be imposed. So what are the controls? Admin control and normal user control, guest control. Okay, so what are the control given to the user? Provide a means of enforcement. So it is protection is the main important task of operating system. Okay, giving protection. Next. We want to distinguish protection and the security. Okay, so what is protection? Protection is to be fixed for the authorized person and also the unauthorized one. Okay, so the operating system should separate the authorized and unauthorized usage. Okay, and here security defends the system against internal and external attacks. Okay, huge range including denial of service, worms, viruses, identity of theft and theft of service. So this is the security. Okay, so protection is nothing but any mechanism for controlling access of process. Okay, so whom can access and whom cannot. Okay, security, it should give the defense like mechanism to stop, to restrict the internal attack from the virus or worms, whatever it may be. Okay, worms, what is worm? What is worm? Yes? We can say virus, both virus and worms are unwanted programs which spoils our system resource. Right? நம்மளோட சிஸ்டமை ஸ்பாயில் பண்ணும் ரெண்டுமே வைரஸ் இருந்தாலும் worms இருந்தாலும். There are different types of worms are available. Trojan horse. Okay, so we can also have different types of external attacks by means of viruses and worms. Okay, so which is an unwanted program actually. System generally first distinguish among users to determine who can do what. Okay, so which user can do what operation? Admin can do what operation, and normal user can access what are the resources. First, it should differentiate these two things. User identities like user ID, security ID, effective ID given by the operating system to achieve this task. Okay, so when I am having the admin right, I can do anything in my system. Okay, that is the user identity, admin ID. Okay, if I don't have the admin rights, that is I don't have the admin ID, then I cannot perform administrative work. Okay, so I cannot access the system. And group identifier allows a set of users. So first one is user identities, include name and associated number as one per user. User ID then associated with all files, process of what user to determine access control. Group identifier allows set of user to be defined and controlled, managed. Then also associated with each process, file privilege escalation allows user to change to effective ID with more rights. So in our lab, okay, students, you are logging into the username students, right? Students, okay, so it's a group ID actually. Okay, after login into a student's ID, you are mapping into your own login ID. That is your user ID. Okay, so differentiate these two. Okay, group ID is different and your own user ID is different. Next. So in protection, it is by providing different access to the users, to different types of users. OS is maintaining the job of protecting the system. And command interpreter system. Command interpreter system where I can give the command and also operating system respond it. Okay. So usually we can have a shell or command line prompt. Command prompt is there to provide to give over the command. Okay. So that the operating system accept the command and give response or do some actions according to the command. Many commands are given to the operating system by control statements which deal with. So in any components I can give command. Okay, so each and every, if I want to give command for IO handling, I have set of commands. Okay, for the networking I have some commands. Okay, so by use of commands I can I can directly give the command to the operating system where that command interpreter or shell interpret the command actually. Okay, which takes the command and also given to the operating system. Next. The program that reads and interprets control statements is called variously command line interpreter, or in Unix based system we can call that as a shell. Okay, where in Microsoft system we can call that as a command line interpreter. Okay, you can also would have also tried the example of command based argument passing. Okay, when you are executing your program, that time you are passing that is runtime input passing. Okay, so that is the example for it. Okay, so command line, at the command line you are giving the command, okay, to control something. Its function is to get and execute the next command statement. Next. And so far we have discussed about the components of operating system, major components of operating system, and what are the responsibility of OS for the different components. Okay, so we shall see what are the services provided by the operating system. Program execution, system capability to load a program into memory and to run it. First job. Okay, first and foremost preference given to the program execution, the services provided by the operating system. Okay, so that is program execution. To load, after loading into the memory, the program gets executed. And IO operations, execute IO operations directly. The operating system must provide some means to perform IO. So to perform any IO operations, it should provide the service. File system manipulation, read, write, okay, execute. So these are the task of OS, services provided by the OS. And communications, exchange of information between the process, inter-process communication, passing the message, okay, or otherwise communicating with other process. Okay, it is done in two ways. Okay, one is it could be implemented in two ways. One is shared memory and another one is message passing. Next, go to the next. So it is a message passing and it's a shared memory. Okay. Kernel, what is a kernel? It is a part of operating system. Okay. So here we have two processes, and through message passing how it is communicating, and by use of shared memory how it is communicating. Okay. So here shared memory is there where the common variables or what are the messages to be communicated among two processes kept. Okay, so that process 1 can access shared memory to communicate with process B. Okay, so this is a common place where the common information or communication information or the message resides. Okay, so that both process can access the shared memory. Whereas here in message passing,